Hey pre-calc students, in this video we're going to talk about degree angles, radian angles, and then how they fit on the unit circle. Okay, we've been talking about angles in a triangle, but you can also have an angle in what's called standard position. An angle in standard position is an angle formed by rotating a ray around its endpoint. The ray is the starting position is called the initial side. And whenever we're doing an angle in standard position, we kind of think about it on the coordinate plane. So I'm going to draw a little X and Y axis here. When I'm thinking about an angle, we always put the initial side of an angle on the positive X axis. That's the initial side of an angle. And then we're going to rotate that initial side a certain number of degrees. And then that will be what's called the terminal side. So the terminal side is the ending side. So you have the initial side, the terminal side, and the angle is formed in between these two. We say positive angles are formed when we rotate counterclockwise. So starting from the x-axis, rotating up is a positive angle. And if you rotate down, in other words, you're rotating clockwise, this would be a negative angle. So if you rotate down, this would be a negative angle. Okay, so we're going to do a little bit of drawing and angle practice. So for each one of these, I'm going to start with a coordinate plane, X and Y axis. For 45 degrees, I'm going to start my angle measurement here on the positive X axis, and I'm going to rotate to 45 degrees. Well, a 90-degree angle would be going straight up on the positive Y axis, so I'm actually going to mark that. So this would be 90 degrees. So a 45-degree angle is going to be halfway in between there. So I'm going to rotate to a 45-degree angle mark, right halfway. So this is a 45-degree angle in standard position. If I wanted to do a negative 90-degree angle, I'm going to start my angle on the positive x-axis, and because it's negative, this means I'm going to rotate down first. And again, I want to form a 90-degree angle. So I want my angle measurement to be rotating down, and I want to make a perfect right angle, so I'm going to go down to this negative y-axis. To do 225 degrees, again, I'm going to always start with my axes, starting my initial side on the positive x-axis. And then I need to think about 225 degrees is, see, it's more than 90, so I'm going to go more than 90 degrees. Okay. It's more than 180 degrees, so I'm going to keep going, go beyond 180 degrees. And in fact, it is 45 degrees over the 180, right? If I do 225 and I subtract 180, I'm going 45 degrees over 85. So I'm going to go halfway between, go 45 degrees, and this is my angle measurement. Sometimes it's also really nice to know what quadrant we're talking about our angles in. So I'm going to actually go back and add these. So 45 degrees is a quadrant 1 angle. Negative 90 degrees is on an axis, so we actually wouldn't put that in a quadrant, but this is a quadrant 3 angle. And then the last one that we'll do is 405 degrees. 405 degrees is, if I start at the positive x-axis, I need to go 90, let's see, I need to go a good bit, don't I? 90, I'm going to go 90 more, so that's 180. I'm going to go 90 more again, that's 270. If I do a 90 again, that's 360, so that's a full circle. And then I need to keep going. So let's figure out how much more I need to go. 405 minus 360, how much more do I need? I need to go an additional 45 degrees. So 45 more degrees if I've already gone the 360. So I'm going to go again, 45 degrees, a little bit more. And there's that angle of 405 degrees. This is a quadrant 1 angle. Okay, well, there's 2 ways we can measure an angle. Most of us are used to degrees, so that's what we were just practicing with. And if I want to talk about degrees, I'm going to go ahead and draw my coordinate plane. And this is my degrees. So starting on the positive x-axis, this is 0 degrees. Going to the positive y-axis, that would be a 90-degree angle. If I keep going and I make a straight line from the x-axis to the negative x-axis, this would be 180 degrees. Okay. If I keep rotating 90 more degrees, this would be 270 degrees. And if I make a full circle, the positive x-axis is also the same thing as 360 degrees. Obviously, I can keep going and I can talk about what would a 400-degree angle look like? What would a 700-degree angle look like? I could also talk about negative angles. What would negative 360 look like? But it's really nice to have these 4 pieces filled out on my coordinate plane, just so I can always constantly see angles in between them as well. So then the next thing we want to talk about is, what is a radian? Okay, to talk about a radian, I'm actually going to go take a look at Wikipedia. Wikipedia has a really great GIF that walks through what a radian is. So we have a radius length r. R is the measure, the radius is the length of 1 radian. So a degree, this is roughly kind of about 57 degrees, but that's 1 radian, which is an angle measurement. There's 2 radians, 3 radians, and a half circle is actually pi radians. And then if we keep going and double that, a full circle would be about 2 pi radians. It's where we get the equation for the circumference from, right? The circumference of a circle is equal to 2 pi r. That's because it's equal to 2 pi radians. Okay, so with this information, if I do my coordinate plane, and I want to talk about my coordinate plane in terms of radians. Okay. A radian is all about, all my radians are dealing with the number pi. So positive x-axis is the beginning, that is 0 radians. 1 radian, right? This is 1 radian. And we don't actually really use this that often, but it is nice to know that 1 radian does fall inside the first quadrant. The big ones that we need to know is the fact that half of a circle is pi radians. A full circle is 2 pi radians. So I can also mark my 90 degrees, which is the top. So that is halfway from 0 to pi. So this would be half of pi is my positive y-axis. And my negative y-axis, which is my 270 degrees in degree language, is between 1 pi and 2 pi, which is about 1.5 pi. But many times we see this written as the fraction 3/2 pi. This is way more common to talk about radians in terms of their improper fraction form. Okay, so when you're drawing an angle in radian form, it's important to know these key values. So we know that the positive x-axis is 0 radians. The positive y-axis is pi over 2 radians. That's a 90-degree angle, pi over 2 radians. Then we have pi radians. We have 3 pi over 2 radians, and then a full circle is 2 pi. Whenever we're doing this, it's best to either if the angle measurement is one of those 4, it's really easy to draw one of those angles. So for instance, if I wanted to draw a pi over 2 radian, I can start at 0 radians and I can go halfway to pi, which is straight up. So this is my pi over 2 radians. If ever I have a value that is not on one of my coordinate planes, like 7 pi over 12, it's really nice to convert all of these so that my denominators are the same. So the first thing I'm going to do is I'm going to draw my original coordinate plane. And rather than have like 2 pi, I'm going to put all of these with a denominator of 12. So like 2 pi would be the same thing as 24 pi over 12. See, I'm using that common denominator. 1 pi is the same thing as 12 pi over 12. And I want 7 pi over 12. So here's, again, we start at 0. And then I'm going to 7 pi over 12. So this is going to happen before 12 pi over 12. Pi over 2 I can write as 6 pi over 12, right? That's half of pi. And so what I need to see is that 7 pi over 12 is actually going to be just a 1/12 over that 6 pi over 12. So I'm going to go just a little bit over 6 pi over 12. And there is my 7 pi over 12, just a little over 6 pi over 12. Again, that reduces to pi over 2, so that's where we know that. Okay, for my next example, again, I'm going to start with my coordinate plane. I have 0 radians, so 0 pi, if I want to think about it still in terms of pi. And I see that I'm doing negative 2/3. So I'm actually going to label my axis going in the negative direction. So down at the bottom would be pi over 2 negative. So that's the negative pi over 2. And then over here I would have negative pi, which is my, again, going counterclockwise when you have a negative angle measurement. Okay, so I need to do negative 2/3. So I'm going to convert into 2/3. So this is 0 thirds, and pi would be negative 3/3, and I need to do 2/3. So if I think about this, I've got 1/3. If I kind of split this up into 3 sections, right, there's kind of this 3 sections of pi. Here's negative 1/3, negative 2/3, and so let me use a different color here. So we'll start on the positive x-axis, and we will rotate down to negative 2/3. Again, negative 2/3 pi. Okay, try the last problem on your own. Okay, I set up my axes. 9 pi over 4 is a fourth over 2 pi, right? So 2 pi is 8/4. So the 2 pi is a full circle, and then I had to go a fourth of the way to pi over that 8/4. So this is over a full circle, and then it's in that quadrant 1. Okay, because radians and degrees are measuring the same thing, we're going to use a conversion factor so that way we can go back and forth between degrees and radians, especially because a lot of us think a lot more in terms of degrees than we do in radians. So sometimes it's nice to, when you're trying to figure out where does this radian belong, sometimes it's nice to convert it to degrees or vice versa. So we're going to use this conversion factor, the fact that pi is equal to 180. So pi radians is the same thing as 180 degrees. So if we multiply by pi radians over 180 degrees, or 180 degrees divided by pi radians, it's the same thing as multiplying by 1. This is going to become our conversion fraction, and so we're going to use this to cancel out whatever unit we have to get a new unit. So we're going to use one of these conversion fractions to do that. Okay, so for instance, if I want to convert each angle that is in degrees to radians, and we're going to answer this in terms of pi. So if I want to cancel out the degrees, I want to multiply by the fraction. I have 80 degrees, and I'm going to multiply this where 180 degrees is on the bottom so that the 80 degrees will cancel. And so pi radians will be on top. Okay. Whenever I do this, I'm going to cancel out the unit that I'm getting rid of, and I'm going to multiply straight across. So I have 80 pi over 180. And this is now in terms of radians. And we just want to see if we can simplify this fraction. 80 over 180 can reduce. I can definitely take a 10 out of both, and then I can reduce 8/18 by 2. So 4/9 pi is my radian form. Okay, try B on your own. Okay, pause the video and check your work. Let's talk about how do we go from radians to degrees. Now, it doesn't have the unit like the degrees does, but I can add the unit. So this is 2 pi over 3 radians, and I'm going to convert this to degrees. So to convert it to degrees, I want to have the radians on the denominator so that the radians will cancel. And so 180 will go on top. The radians will cancel, and I'm going to multiply straight across and then look for ways I can simplify. So 2 pi times 180 degrees is 360 pi degrees. And then 3 times pi is 3 pi. I can simplify this because my pi's will cancel, and 360 divided by 3 is 120 degrees. What this is saying is that 2 pi over 3, this placement, this angle, is the same thing as 120 degrees. It's going to be the exact same measurement, just in 2 different units. Think about this as like meters versus inches, right? We're talking about 2 different ways to measure the same exact length or the same exact angle. Okay, my last example is 4.5 radians, so I need to get rid of radians. So I'm going to multiply this by pi radians on the bottom and 180 degrees on top. The radians will cancel, and I'm going to turn 4.5 into a fraction by putting a 1 underneath it. 4.5 times 180 degrees is 810 degrees. And the pi's are not going to cancel. 1 times pi is just pi, but this is 108 degrees divided by pi is the same degree measurement as 4.5 radians. If I wanted the decimal form of this, I could also actually do this math, and I would get 257.8 degrees. Okay, so the last thing that we'll talk about really quickly in this video, you don't even need to necessarily write this down, but we had exact trig values that we've talked about last week. So our exact trig values we found using special right triangles. And we found that sine of 30 degrees was 1/2, sine of 45 degrees was square root 2 over 2, and so on. Well, now that we're talking about degrees and also radians, so for instance, 30 degrees is the same thing as pi over 6 radians. So this is the same value as sine of pi over 6. Okay. To talk about all of these angle measurements beyond what fits in a triangle. So we're talking about angles that go beyond 180 degrees. In other words, a full circle, or even beyond a full circle. We want to think about this in terms of a coordinate plane. So we're going to see all these same values, but now we're going to expand them into the coordinate plane system. So this is what the unit circle is. The unit circle is a circle. It has a radius of 1, and it's centered at the origin. So right here is the point 0, 0. And then it goes out on the x-axis, the y-axis, and we have the positive x-axis. We have an intersection here at the circle at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. You'll notice some key features. So we have 0 and 2 pi, also known as 0 degrees and 360 degrees. Our other key pi and degree are key radians and degrees. And then we have a few more in each quadrant. What the unit circle is a visual organization for sine and cosine for some angle measurements. For instance, we have 30 degrees, 45 degrees, 60 degrees. What we don't have would be like 70 degrees, we don't have that angle measurement. The unit circle is a good use for some degree measurements and some radian measurements. And how we use the unit circle is cosine is the x coordinate. So cosine of 30 degrees is square root 2 over 2. And sine of 30 degrees is the y coordinate, so 1/2. So again, this is just a visual organization for sine and cosine values of angles beyond the 30, 40, and 60 that we found a few days ago. The goal for this would be to memorize this. It's really helpful and useful to be able to find sine and cosine values very quickly in your head if you have this memorized. So I'll post a few extra videos that help walk through what the unit circle is, how it's formed, and memorization tools and tricks that you can use to help you memorize the unit circle.